Yes, I'm John Sarter. Thanks for having me here. It's a pleasure to be here. Yes, I work for a bidirectional company called dcbel, and I've also been a California licensed general contractor, designer builder since 1984. And all I will build now is all electric and either passive house certified or using passive house methodology because it's so efficient. And it's really that's where you need to start is, efficiency first to reduce your energy consumption. But getting into my talk, I'm going to talk about bidirectional EVs and EV charging and connecting the dots for a sustainable future. So first off, what is bidirectional charging? It's a process by which a bidirectional capable EV works with a bidirectional charger inverter. It has to be both. And that inverter charges and discharges the car's battery to operate electrical devices in the home or building or through the home to the grid. And what this can do is if you isolate your home from the grid in the event of an outage, it can provide unparalleled resilience for your home because, and the average EV is able to power your home for 3 days or more. And the larger batteries they make now, even longer, a week or more. And what this also does, it allows you to monetize your EV while it's sitting there stationary by selling that power back to the grid. And I'll talk a little bit more about that as we go forward. So a little bit of terminology. V to X basically means vehicle to everything. And that's kind of broken down into subcategories. The first one is vehicle to load, where your vehicle can power loads through maybe an extension cord like the Lightning F-150 here in this photo. And then vehicle to building, where your vehicle can power essential loads in your building and potentially the whole building, depending how your panel and your breakers are set up. And then there's vehicle to grid, which exports energy from the car through the home or building and to the grid. There's a couple different types of bidirectionality. One of them is DC power, and what that does is it exports the DC energy in your car's battery or a stationary battery to a site-based inverter, which then converts the DC energy to AC for use in your home or exporting to the grid. And this really, using a vehicle is virtually the same as using a stationary battery plus a stationary inverter. It's just that the battery is on wheels, essentially. So the manufacturers can set the limit as to how much they will allow their vehicle to export in both quantity and continuous discharge, the rate of discharge. And they can help safeguard their warranties in that way. The company I work for, our technology will actually allow you to power your EV directly through from your solar into the vehicle very quickly at 1 mile per minute. And then that way, only one inversion is required for that DC energy to go back to AC to power your home or to the grid. The other way to do it is AC bidirectionality, and this requires a modification of the vehicle's onboard inverter. It's a little bit more expensive to do this because it's a hardware change in the vehicle. And there's a lot of OEMs that are doing this right now with mostly proprietary systems and mostly in the higher end of their ecosystems. This does have a resilience benefit for the owner and a monetary payback, but it really doesn't maximize the potential benefit to society as a whole. I'll get to that in a minute here. A little bit about our charger. It's the first universal DC bidirectional charger to be certified in the USA and the North American market. We just received that in June. And by universal, I mean we're EV agnostic. So we will support any EV who will work with us. It's also a solar inverter, as I said, so it's kind of an all-in-one device, and it helps save money for your entire system in this way. It's a 2-port charger. One of them is level 2 AC from the grid, and the other one is we call it level 2.5 because it's DC charging. It's a fast charger for your home, and it gives you a rate of charge that's about twice a normal level 2 charger. It also includes a stationary battery management system, and we've partnered with LG Chem for this currently. We can also support other high voltage batteries. And it also has a home energy management system that optimizes and prioritizes the energy flow within your home from your solar, your battery, your car to the grid and from the grid. And it's SunSpec certified for grid export and interoperability, which is required for California Rule 21. Now, in addition to our technology, there's a lot of new chargers coming onto the market from Wallbox, Emporia, Enphase, Delta, Fermata, and just recently SolarEdge announced they're going to have one also. So it's definitely an up-and-coming thing that everybody's kind of jumping into. As far as available, these are AC bidirectional systems that are proprietary for all of these different vehicles, and there's quite a number and still growing again. So for EVs that are capable right now of DC to V to X, V to X export, we have the Nissan Leaf, Mitsubishi Highlander. Volvo has committed to making all of their vehicles bidirectional, and we've partnered with them also. The Kia Soul, and Tesla is saying all their EVs will be bidirectional by 2025. GM says by 2026. And there's a new partnership between Ford, Honda, and BMW, whereby they are going to partner and offer grid services for people's vehicles to be able to monetize the vehicle, as I said. And on the right again is all these proprietary AC systems from the different manufacturers. So for maximum societal benefit, really all of the EVs and the bidirectional chargers should be interoperable. And in this way, you could take your EV and you could provide support, emergency power support to your neighbor that might have a medical condition, or a community center that might need power. You can basically start to share energy within your community for resilience, and it sort of creates a mobile microgrid of energy, you might say, without having to use the utility wires. You're moving the energy around in vehicles instead of with wires. The thing that I'm really excited about with V2X is I really feel it represents a silver bullet for sustainability, and it will enable us to decarbonize the built environment, transportation, and energy sectors simultaneously and potentially quite rapidly. So this isn't really new technology. There's over 120 projects operating worldwide, and there's been many years of experimentation, policy reform, and standardization. And we're really ready for it to enter a fast-paced multi-year expansion period, which I'm pretty certain is going to happen. And there's a link to a white paper here that give you more information on the history of bidirectional charging. So currently, the grid communication standards, this is something we've been waiting on for a long time, are completed through the ISO 15118 interoperable CCS DC bidirectional charging standard. So this will enable these standardization initiatives to ensure interoperability, and also for this system to work with any different charger, CCS, NACS, CHAdeMO, all of them basically. So these standards offer a clear upgrade path for EV makers and charger makers who wish to provide bidirectional support going forward. The communication standard for the grid is IEEE 2030.5 CSIP certified, which is mandated by California Rule 21 for grid interoperable inverters and battery systems. And this allows grid operators to send signals for when they need power for grid-connected V2G inverters or batteries to maintain network stability. And then the OpenADR protocol, which you're probably familiar with, has been developed so that service providers and aggregators are able to bundle all of these various assets into a virtual power plant, which can then seamlessly interface with all kinds of different devices, water heaters, batteries, EVs, in order to operate aggregated demand response services to system operators. I'm kind of going through these fast, so please refer back to it. I have a lot of links in here that you can check later on too. So the value of virtual power plants, it really allows the aggregation of all these distributed assets into large pools of energy storage reserves, and that can help reduce the need or eventually eliminate the need for fossil fuel peaker plants. And scaling up these assets is really the key now at this point. So a little bit about scale. California currently has 1.5 million EVs. If each one of those EVs has an average of, let's say, 60 kilowatt hours, which is pretty average, maybe on the low side, that equals 90,000 megawatt hours of potential energy storage. That is 225 times the largest grid scale energy storage project in existence in California at the Moss Landing power plant. By 2035, California expects to have 12.5 million EVs. And if you do the math on that, it ends up being almost 2,000 times the largest grid scale energy storage in existence. And the beauty of this is that it's widely distributed right where you need these energy assets in homes and businesses and communities throughout the state. Oops. As far as demand response numbers go, California's highest peak demand event was on September 6th of last year, and it was 51,426 megawatts. So that same 12.5 million EVs, if they were discharging 10 kilowatts, which is a very modest number, that would be almost, well, more than twice as much of that peak demand event that we have available in instant power response. So that's another beauty of V2G. It really represents an ever-expanding capacity for demand response and for resilience within your homes and communities. Thought I took those out. Anyway, so what we have now is we have the bidirectional EVs, we have the bidirectional charger technologies, we have the grid communication protocols, and we have the fire codes and safety standards because they're essentially the same as stationary batteries if it's a DC export. AC systems are a little bit different. If you are discharging directly from your vehicle, you've got to be careful and make sure you have a transfer switch or a way to shut your home or business off from the grid so you're not exporting energy to the grid during an outage. So a couple of things that are still kind of needed, I think, are greater access to VPP markets. Currently, I believe only the IOUs are able to have these and arrange these VPPs. And in my opinion and the industry's opinion, this should be available to CCAs and even private aggregators so that we can really scale up these resources. The other thing that I think is really important is starting to plan for pre-wiring for this technology. Because if you do it when you're building a home, you're talking about maybe hundreds of dollars extra for the wiring. But if you try to do it later, it can be thousands or even tens of thousands of dollars to add on later. So every building that gets built that doesn't have this pre-wiring, or at least some conduit for it, is really going to be sort of a stranded asset going forward into the future. So to this end, we've developed what we call an electrification and community resilience, or ECR document, with industry experts, EPRI 2050 partners who are consultants to the utilities. Our company, Nuvi, is an aggregator company, and BayREN is the company that developed the ISO 15118 standard. Sorry. I'm not good with these animations, but anyway, here we go. So I'm not going to go into these documents in detail. I've provided them to all of you to look over. And the first one is a 4-page document that has electrification, wiring, plus energy storage and V2X capability wiring. And then at the suggestion of 2050 partners, they said maybe a lot of jurisdictions are already going to full electrification. So why don't you develop a document that is just specific to energy storage and V2X. So that's what we did. We have 2 different documents, and we also have a little diagram that kind of shows the ideal locations of these items within a home and garage to minimize the wiring costs involved. And then a table where your electrician can fill in the cost for your particular build. So if any of you want to go over this later with me, you have my contact information, and I'd be happy to work with any of you. And it's designed to be a living document as well, and kind of adaptable to new technologies as they come forward. So that's my presentation.